Hello everyone, my name is Mahanaim and this is presentation 3 of my Capstone project on a comparative data analysis of mortgage loan approval rate prediction. This project investigates systemic disparities in mortgage approvals, focusing on two states, Mississippi and South Dakota. I'll take you through the project's journey in today's presentation, starting with a background and problem description, and we will delve into the data preparation, visualization, and moving to the predictive model developed, and finally discuss the key insights and actionable recommendations. Homeownership has long been a cornerstone of wealth building in the US, yet it remains out of reach for many minority groups. For instance, as of 2022, only 45% of Black Americans owned homes compared to 75% of white Americans. The historical factors like redlining and discriminatory lending practices persist today in more subtle forms, often reflected in the approval rates of mortgage applications. This project builds on these systemic issues, focusing on their manifestation in Mississippi, and a state with a high Black population, and South Dakota, a predominantly white state. The existing researches are particularly studies leveraging Home Mortgage Disclosure Act data has shown significant racial disparities in loan approval rates, even when financial metrics like credit score and incomes are comparable. Yet most studies examine these trends at a national level. This project fills a research gap by conducting a state-level comparative analysis, providing a deeper understanding of localized disparities and how they contribute to the broader inequality landscape. At this heart of this analysis is the disparity in mortgage loan approvals across racial lines. Despite having comparable financial qualifications, minority groups, particularly Black applicants, face higher denial rates and are often subjected to high-cost loans. This project aims to identify the underlying pattern and systemic biases that perpetuate these inequities and suggest ways to address them. The scope of this project focuses on racial disparities in loan approvals using the 2023 HMDA data for Mississippi and South Dakota. I examined financial and demographic variables such as credit history, loan amount, and income by excluding other demographic aspects like gender, and I ensured a targeted analysis of racial and geographic disparities in these two states. The primary goal of this project is threefold. The first is to understand how racial and geographic factors affect loan approval outcomes. The second is to uncover potential systemic biases within the lending process. And the third one is to recommend actionable steps for promoting equity in mortgage lending practices. I utilize the 2023 HMDA data complemented by the US Census Bureau demographic data for socioeconomic context. The raw data set consisted of 122,016 instances and 99 attributes, which I reduced to 94,504 instances and 40 attributes through rigorous data cleaning and feature selections. Key variables such as loan amount, applicant income, and denial reason were prioritized when we do the data cleaning. The merging of datasets by census tract enriched my analysis with geographic and demographic insights. Census data provides additional socioeconomic context, such as racial composition and income distribution in the applicant's community. The data challenge and preparations. Missing values were handled systematically, especially for critical attributes like race and income, to ensure the data completeness. Redundant attributes were removed to streamline the dataset, preserving only the most relevant factors for analyzing approval disparities. Outliers in financial variables such as loan amount were transformed to prevent skewing the model's predictive accuracy. My predictive models were evaluated against defined KPIs, including achieving an accuracy rate above 84 and precision above 80% and an AUC value of between 0.8 and 0.9 for a higher predictive power. These metrics ensured robust, actionable predictions suitable for addressing real-world challenges in mortgage lending. The tools I used to visualize are the Tableau for interactive visualization of loan patterns and RStudio for advanced customizable visualizations. This visualization highlights systematic disparities in income and loan distribution by state and race. It reveals significant income differences with white applicants in Mississippi and earning the highest incomes. Similarly, loan distribution reflects these racial disparities as white applicants also receive the largest loan amount. Black applicants in Mississippi are represented but receive considerably lower loans amount compared to their white counterparts. Additionally, the geographic contrast is evident, with South Dakota showing lower overall economic activity and fewer loans compared to Mississippi. This visualization underscores the persistent inequalities in both income and loan allocations across racial and geographic lines. This visualization shows loan application outcomes across race and state, highlighting key trends and disparities. White applicant exhibits higher approval rate compared to black applicants, with more pronounced differences in Mississippi. Mississippi also has significantly higher application volumes and approval than South Dakota. In terms of loan amounts, white applicants dominate approvals in both states, receiving larger loans overall. However, disparities are evident in denial rates, particularly for black applicants in Mississippi, where approvals and loan amounts favor white applicants, while black applicants face disproportionately high denial rates. These trends reveal systemic inequities in loan application process. This visualization explores the types of loans and reasons for denials, revealing significant disparities. Black applicants are more likely to receive high-cost mortgages, reflecting affordability challenges. State-level differences show Mississippi has a higher prevalence of high-cost loans compared to South Dakota. Common reasons for denial includes credit history and debt-to-income ratios, which disproportionately impact black applicants. Additionally, a significant portion of denials occur in the early stages, particularly affecting minority groups. This insight emphasizes structural biases in loan costs and denial process, highlighting systematic challenges faced by the minority applicants. This visualization in this slide examines disparities in mortgage types and reasons for denial across race and geography. Black applicants are disproportionately represented in high-cost mortgages compared to white applicants, highlighting affordability challenges. At the state level, Mississippi has a slightly higher prevalence of high-cost mortgages than South Dakota. Denial reasons vary significantly, with credit history and debt-to-income ratios being the primary factors for Black applicants. Regionally, Mississippi sees more denials related to credit and income issues, whereas South Dakota focuses more on collateral concerns. These findings underscores racial and geographic inequities in mortgage affordability and the systemic challenges present in lending practices. I developed 4 predictive models: ensemble, logistic regression with bagging, decision tree with bagging, random forest, and gradient boosting. These models were chosen for their ability to handle binary classifications, capture complex relationships, and provide interpretability in financial decision making. These models were rigorously evaluated to ensure they met the project's KPIs. We will see the justifications on the next slide. Ensemble logistic regression with bagging is chosen for its straightforward interpretation, making it suitable for analyzing the direct effect of race and income on loan approval. Ensemble bagging method improves robustness by leveraging results from multiple decision trees, which helps reduce overfitting and increasing reliability. Random forest leverages bootstrapping and majority voting to improve prediction accuracy, especially useful in identifying complex relationships in approval decisions. Gradient boosting effectively uncovers subtle relationships in data, builds strong learners sequentially to capture complex patterns, and it's highly flexible and customizable for different datasets. This slide presents the modeling process and results for evaluating different machine learning algorithms. The workflow includes the data preparation step like filtering, imputing, transform, variable, and partitioning data into training and validation sets. Multiple models were tested, including ensemble bagging with logistic regression, decision tree, high performance forest, and gradient boosting. Each model was evaluated on metrics like accuracy, sensitivity, precision, F1 score, and ROC. The decision tree model under ensemble bagging achieved the highest accuracy of 99%, along with strong sensitivity and precision. When we compare the predictive models, all models performed exceptionally well, with accuracy scores ranging from 95% to 99%. The decision tree with bagging emerged as the top performer in accuracy, precision, and interpretability. However, other models like gradient boosting showed strengths in handling complex interactions, making them equally valuable for specific applications. After a comprehensive evaluation, the decision tree with bugging was selected as a champion model. It achieved a remarkable accuracy of 99% and provided clear interpretability, which is critical for understanding the factors driving mortgage approvals and denials. Its high precision minimizes risk associated with approving unqualified applicants. The model surpassed the KPIs, demonstrating high predictive accuracy, reliability, and fairness. This achievement underscores their robustness and suitability for addressing the challenges in mortgage lending. The targeting accuracy was above 80 and 99% was achieved in the result. Overall model accuracy, our target was at least 84% and we achieved 99%. The AUC curve, we achieved one of AUC curve, which is above our targeted value. The key insights: the analysis highlights stark racial and geographic disparities in mortgage lending. For instance, income disparities and systemic biases disproportionately affect minority groups, particularly in Mississippi. Recommendations include introducing equitable lending policies, state-specific interventions, and enhancing lender training to mitigate the biases. In conclusion, this project sheds light on the systemic inequities in mortgage approvals and emphasizes the need for targeted solutions. The findings demonstrates the potential of data-driven approaches of fostering equitable financial systems, encouraging policymakers and financial institutions to reevaluate and improve their practices. Based on this project, my recommendation focuses on 3 areas: improving equity in lending practices through advanced predictive tools, increasing awareness among lenders of potential biases, and implementing state-specific policies to address unique challenges faced by different demographics. Thank you for your attention. I hope this presentation has provided valuable insights into the systematic challenges in mortgage lending and how data analytics can help address them.